Alright class, this is number 26 in section 4.8. This is the plane with the speed of 550 miles per hour. And then we're given two angles to it, 16 degrees, and then a minute later, 57 degrees. Okay, so we'll have the plane start out right here. Alright. There we go. Perfect. Plane. Looks like this one crashed before. Looks like only half a plane. Anyways. Alright, so our angle to the plane at the beginning is 16 degrees. And we're trying to find this height y. Okay, after 1 minute, this plane flies to, we'll say right here. Okay, and it takes 1 minute to get there. And then we have another triangle to it. Again, it's a right triangle, but this time the angle down here is 57 degrees. Okay, and the plane is traveling at 550 miles per hour. Alright, well, the first part of this problem, we'll just set up this orange triangle right down here. Okay, 57 degrees, and we know we're looking for this height y, which isn't going to change. The plane stays the same altitude, and I'm just going to put a variable in up here, x. We'll just call this x for the time being. Okay. The other triangle is a little bit trickier, but I know part of its distance by using dirt. Distance equals rate times time. I know it's traveling at 550 miles per hour. And I know that it's going to travel that for a certain amount of time. The time is in minutes. In order to use this formula, the time needs to be in hours. So 1 minute would be 1/60th of an hour. The hours would cancel. So my distance then would be 550 over 60. Or let's just leave it as 55 over 6. Okay, so I'm going to erase this part so I got a little bit more room here to work with. But the distance then the plane travels at 550 miles per hour for 1 minute is 55 over 6. So that's this distance right here, 55 over 6. So the second triangle, I'll draw it in blue. Again, this distance is y. This distance is split into two parts, x and 55 over 6. And this angle is 16 degrees. Okay, so this problem is more difficult than what we've seen. All the other problems, we only had one variable to deal with. Okay, and then we could solve for that variable. This problem has two variables that are going to go into our function. Okay, the function we're going to use is tangent. So this problem would be tangent 57 equals y over x. I'm going to solve it for y. So y would equal tangent 57 times x. I should put the x in front. X tangent 57. Okay, by multiplying both sides of this equation right here by x. Okay, the other equation would be tangent again. Tangent of 16. Okay, which would equal y over x plus 55 sixths. Okay. Solving for y, I'm going to multiply both sides by the denominator here. Okay, so hope you're able to follow this step. This would give me x tangent 16 plus 55 sixths tangent 16. And all of this would equal y. So I'll rewrite it over here. Y would equal x tangent 16 plus 55 sixths tangent 16. So I have two equations and two unknowns. This is how far we got in first hour today. And from here, I just told the students to put it into your calculator. This would work. I must have put it into my calculator wrong that hour, because if I just did it again, put this in correctly. If you put these two equations in correctly, you're going to get a graph that looks something like this. I'll draw in the black line. I believe the black line, actually I don't know which is which off the top of my head, but one of them looks like this, and then the other one comes in like that. This spot where they cross, you can find the intersection. It's going to give you an X and Y point. The Y is the answer you're looking for. Okay, the X will be this distance here. The Y of that point will be the altitude, and that's what we're looking for in this problem. Okay, so I'll challenge you to put that into your calculator correctly. The answer is not in the back of the book, so I guess I can just give it to you here and see if you can get the right answer. Pause for a second if you want to try it first. The answer is 3.23 miles. All right, hope this helps.